Okay, in this video we're going to explore confidence intervals when comparing two proportions. So let's go ahead and dive into this question. So suppose we surveyed a total of 1,000 adult Canadians about reform to the Canadian Football League from Ontario and Alberta. We found that 32% of people in Ontario supported reforming the CFL, whereas the percentage in Alberta was 43%. Construct a 90% confidence interval for the difference in support for reforming the CFL between Alberta and Ontario. And then we have a little note here that says, assume that 38.4% of the people surveyed were in Ontario and 23.6% were in Alberta. And what we notice just kind of immediately is if we take 38.4 plus 23.6, this doesn't equal 100%. So 38.4 plus 23.6 gives us 62%. In other words, 38% of our survey respondents are from elsewhere in Canada. But for this particular question, we are asked to construct a 90% confidence interval for the difference in support reforming the CFL between Alberta and Ontario. So we're just going to focus on Alberta and Ontario. So let's first go ahead and look at this question and think about, can we use a normal distribution? Well, we assume that they are independent and that there's randomization in the survey itself. We have to assume that. It doesn't tell us that in the question. We also assume that 10%, so we'll write some of this down. So independent, yes. Random, yes. We look at this and we know that it's less than 10% of the population because 1,000 Canadians is certainly less than 10% of the total population. So yes, and we're going to look for n times p greater than or equal to 10 and n times q greater than or equal to 10. Well, for both Ontario and Alberta, so if we said that P1 was equal to Ontario and P1 is equal to 32%, 0.32, and P2 was equal to, not Ontario, we're looking at Alberta, and P2 was equal to 43%. Well, we can almost assume that n times p, n times q is greater than or equal to 10. But let's go ahead and just look at some of the additional information that the question has given us before we can resolve that. So let's look at our total sample size. So we have 1,000 adult Canadians, but we're told this piece of information right here. So we can calculate the number of people that were surveyed in each of these provinces. And we can do that by the following. So if 38.4% were from Ontario, that's this value right here. So 0.384 times our total sample size of 1,000. So 0.384 times 1,000 is equal to 384. We can do the same thing for Alberta. So 0.236, that is the percentage that we're from Alberta. 0.236 times 1,000 will give us 236. Okay, so then we can go 0.32 times 384. So 0.32 0.32 times 384 gives us 122.88. So that is greater than or equal to 10. By default, since Q is greater than P in this case, we also know that Q is greater than or equal, N times Q is greater than or equal to 10. And we can take this here and we can say 0.43, that's our value for P, right, that we identified right here, times 236, 0.43 times 236, well, this is equal to 101.48, so we'll just say yes and yes. So our assumptions and conditions for a normal distribution have been met, so we can go ahead and work towards solving this problem. So when we're comparing two proportions, and that's what we're doing here, so we already said that P1 was equal to 0.32, and this was for Ontario, and we said that P2 was equal to 0.43, and this was for Alberta. Well, that means that Q1 is equal to 1 minus P1, so is equal to 1 minus 0.32, which gives us 0.68. And Q2 is equal to 1 minus P2, which is equal to 1 minus 0.43, which is equal to 0.57. Well, perfect. Now, importantly, we need to identify our sample size for both Ontario and Alberta. And lucky for us, we've already calculated this. So we calculated our sample size right here. So N1 is equal to 384. So N1 is equal to 384. And N2 is equal to 236. So now that we have that, we need to go ahead and calculate our standard error. Of course, we are working towards a confidence interval, and we remember that the equation for the confidence interval is equal to the estimate plus or minus, in this case it's Z star, times our standard error. And in this case, it's going to be our standard error of P hat 1 minus P hat 2. Okay, and we recall that this is called, I did this badly here, that this part here is also called our margin of error, or our ME. So we need to be able to calculate our standard error of P hat 1 minus P hat 2. So let's go ahead and calculate that right now. So our standard error of P1 hat minus P hat 2 is equal to the square root of P1 hat times Q1 hat divided by N1 plus P2 hat times Q2 hat divided by N2. Okay, this will just be the equation that you work from when comparing two proportions. So let's go ahead and put this in. So is equal to the square root. Well, P1 hat was equal to 0.32, so 0.32 times Q1 hat, which we said was 0.68, divided by our N1, which we said was 384, plus our P2, so P hat 2, so 0.43 times 0.57 divided by 236. So this will become our standard error. So let's go ahead and do this. So 0.32 times 0.68 divided by 384 gives us a very small number, so we'll just store that in our calculator. And we'll do the same thing, 0.43 times 0.57 divided by 236. Also a very small number, so we'll just store that. And what we're going to get here is the square root of 0.001605. And it keeps going, so we'll just take the square root of that value. And what we get here is a value of 0.040065. Whoops. 65. And we can round this then to equals approximately 0.04007. So we now have our standard error of p hat 1 minus p hat 2. And now we have to establish our confidence interval. So as we've already written, our confidence interval is equal to our estimate plus or minus our margin of error. Well, we haven't really established our estimate, so let's go up to the question and let's just double check what the question is asking us. So we're asking for the difference in support for reforming the CFL between Ontario and Alberta. So what is the difference? Well, all we're going to do here is we're going to take P1 minus P2 plus or minus our Z star times our standard error of P hat 1 minus P hat 2. And I guess technically these are our samples, so we'll put little hats on them to reflect that they're the proportion of our sample. And so what we get here is then we get our 0.32. So 0.32 minus 0.43 plus or minus our Z star times our standard error. And we've already calculated that. We calculated that right here to be 0.04007. So we can just work through this. 0.32 minus 0.43 gives us negative 0.11 plus or minus our Z star times 0.04007. Okay, now importantly, we need to identify what is our critical value for Z star. So let's just visualize this for a second. So we have our normal distribution centered around 0. And we are told that we are looking for a 90% confidence interval. So let's go ahead and look at this. So if we're looking for 90%, well, that means that there's 10% of observations that wouldn't be accounted for, and it's symmetrical, so 5% in each tail. So if we're looking for the area to the left here, we would be looking for 0.95 to get our critical value. So let's go to our Z table. And what we're going to do is we're going to look for the 0.95. That's the area to the left. And what we see is that that value occurs somewhere between 1.64 and 1.65. So what we're going to say is that it occurs pretty much halfway between it, and we're going to say it's 1.645 is our Z star. So is equal to negative 0.11 plus or minus 1.645 times our standard error of 0.04007. So 1.645 times 0.04007. So negative 0.11 plus or minus 0.0659, and we'll round this to 4 decimal points, so 92. And then we can just calculate our confidence interval. So negative 0.11 minus 0.06592 gives us negative 0.1759. And negative 0.11 plus 0.06592 gives us negative 0.04408. And just like that, we have created our 90% confidence interval for comparing the difference between Ontario and Quebec.
That's it for this video, but if you found that it helped make statistics easy, consider showing your support by giving the video a like. And if you still need more help with statistics, then consider subscribing to the channel if you haven't already. I look forward to solving many more problems with you next time.